since this is 9.3, we're going to be evaluating them. So you have two different types of logarithmic functions. You have log, and then the inverse of that's going to be exponential. So you have common log, and then you have natural log. We're going to be dealing with common logarithm right now. So you're going to have a common logarithmic function, and that's written as log with a base as a subscript, base b, with the argument, and the argument's represented as x equals y. And then, just so you know, if you don't have a base and it's like log 24, we're saying that we have log base 10 argument 24 equals y. So it would be, so if we represent our variables here, b equals 10, x equals 24, and y would equal y. You would evaluate this with just a log 24. Then you have the inverse of a common logarithm to be an exponential form. So we dealt with exponential form in like the previous two sections. So exponential function. An exponential function involves these variables. So this is the base raised to the y, and it's going to be equal to the x. So it's base b raised to the y equals the argument x. Okay. So suppose we had, so we're going off of this example, we have log 24. So we're saying log base 10 argument 24 equals y. We're using the exact same values here to set up our exponential form. So when we set up our exponential form, oh, I want to move that, it's too close. Right. Something like that. We're going to go ahead, let's relabel that. B equals 10 and x was 24. So the correct form is going to be base 10 raised to the y equals 24. Okay. So this formula right here is an inverse of this right here, including the base 10. And we do have other bases that are available to us. So when we're solving this, let's read the instructions. Again, this is 9.3. It says, write each equation in exponential form. We're going to do that with numbers 1 through 4. So we have b, we have b equals 4, x equals 16, y equals 2. So it's 4 raised to the second equals 16. And this is the whole solution. For number 2, we have b equals 5, x equals 0.2, and y equals -1. So 5 raised to -1 equals 0.2. Number 3, b equals 8. X equals 1, y equals 0. So 8 raised to 0 equals 1. Then we have b equals 23, x equals 1, y equals 0. 23 raised to 0 equals 1. Through 7, we're going to go from exponential form to logarithmic form. And we're doing common log. Just make sure we have this correct. I want to label these for you. It's not necessary to label them. It's just a way of organizing your work. So this one's going to be b equals 2. Y equals 4 and x equals 16. So it's log base is 2, argument is 16 equals 4. Both sides of the equation is the solution. So this next one, b equals 27, y equals 1/3, x equals 3. Log of base 27, 3 is the argument, equals 1/3. I would put the argument in parentheses or the base parentheses. I just typically put the argument in parentheses. So this is going to be b equals 1/4, y equals -2, and x equals 16. So it's log 1/4 is your base. Remember, that's a subscript. So I'm going to put that in parentheses. It's up to you. Equals -2. This is just one of the situations where I don't want to get confused with the numbers. And then for this next one, part 8, we're just going to evaluate. And we're just typing that into Desmos. Logs that are in our homework and in the Desmos calculator. Someone earlier said, like, change a base. We're not doing that. I know that that's what you're going to learn in another class or you've previously learned, but we have a calculator that allows us to do a little bit more. So remember, using Desmos on the test. So it's log A. It's this button. So it provides you with that subscript. And then if you notice, it has the parentheses for the argument. And we just type that in. So the answer is 2. That's all it wants us to do. That's under functions, and then you go calculus. It's like the second one, I think. Yeah, first one, second row. Press that again. Sorry. So your base is going to be 64. Or you can just keep on using it. Just erase that. So function, calculus, log A, 64, and then 8 is argument. They got half. We don't want decimals, we want fractions. So 1/2. And then log 3 of 1/27, that should be -3. 3 of 1/27. -3. Okay, so down here it tells you how to write the common log, but we also haven't learned natural log. Natural log is ln, not ln, but ln. It doesn't have a base, so you just write the argument after it. The inverse of ln is e to the x. I think that's it. The different log that we've been using, this is going to be the first row in calculus, and it's going to be all the way to the right, I believe. So it's going to be log. So log 100 is 2. Log of 0. 1, 2, 3 zeros and then 1, negative 4. Now we have an ln, so ln of e, this should be negative 3. So here's what you need to know. ln of e always equals 1. But that negative 3 is going to come out in front, so it becomes negative 3 ln of e. This is negative 3 times 1 equals negative 3. That's how you do it longhand. ln is in the first row, second column. ln of e, you're going to have to type it in for negative 3. And the ab, negative 3. And then we have the ln of e, 10. This exponent goes in front, so it's 10 times ln of ln of e, so 10 times 1, or times 1 equals 10. So we do that one more time. Instead of the negative 3, we're going to use 10. That's what we get. Now this one says to use 4 decimal places. Should be fairly easy. So this is going to be log of 200. I'm very specific. Please use 4 decimal places. That's what the answers, it says approximate value, round 4 decimal places. Check when you do an exponential form. Okay, so exponential form of this would be 10 raised to the answer equals approximately 200. So the answer here is 2.301. So 10 to the 2.301 is approximately 200. But it's not asking for that, it's asking for this evaluation. So this one's going to be log of 0.074. So I get negative 1.1308. To check it, it'd be 10 raised to negative 1.1308 is approximately 0.074. So 10 raised to negative 1.1308. 1308. So there you go. Make that 3 of 4. ln of 200 function, calculus, first row, second column, 200. So log and ln give you different values. Excuse me. We don't want equal signs. I'm supposed to be using approximate. So 5.2983. If you're going to check it, it would be e raised to the 5.2983, approximately 200. So ln of 1.005. This is going to be like 2.7. Oh no, it's even crazier number. 0.0050. And to check that, e raised to the 0.0050 give us approximately 1.005. The boxed values are the solutions. All right, so now we're going to graph this. Let's clear this. And we're just saying y equals log base 3x. This is a growth, and it has a horizontal, doesn't have a horizontal, but it has a vertical isotope at 0. So it says rewrite into exponential form and select values for your first y. exponential form is going to be 3 raised to the y equals x. So it says rewrite exponential, select values for your first y. Okay. So this is a little different. Oh, these are the instructions that you need for when you're plotting it. 4 points and the asymptote. That's what it needs when you plot it. So we're going to put our y first. So let's just do 0, 1, 2, 3, 4, 5, 6. Actually, 0, 1, 2, 3, negative 1, negative 2, negative 3. So 3 to the 0 equals 1, 3 to the 1 equals 3, 3 to the 2 equals 9, 3 to the 3 equals 27, 3 to the negative 1 equals 1/3, 3 to negative 2 equals 1 over 9, 3 to negative 3 equals 1 over 27. We did these already in another graph. So then we plot our points, 1, 0. Remember, this is just a sketch. It's a rough draft. No, 3, 0. Oh dear. So it's 3, 1. So it's 1, 0, 3, 1, 9, 2. So we had to build the x. And then the other one was 27, 3. All right, 1, 0, 3, oops, 1, 0 is down here. 3, 1, 9, 2, 27, 3. So there are 4 points. We connect the dots, just a curve. And then we have again a vertical asymptote. So this is going to be x equals 0. So these are the 4 points. And then the asymptote, vertical asymptote of x equals 0. And this is a growth. And then I would also say that we need to give domain and range here. It's not asking for it, but let's go ahead. So domain, it's gonna approach 0, go to infinity. Range, it's going to be negative infinity to infinity. There's nothing stopping it from, right? There's nothing stopping it from going down. There's nothing stopping it from going up. A graph, like they're just showing you exponential and then log. And then you have the properties of each of those, domain and range, the asymptote. This is just a summary of what we've been graphing, where the bases are always greater than 1. Remember, so the base cannot equal 0. So your base cannot equal 0. I do need to talk to you about scientific notation. So let's go ahead and learn about that. So you have standard notation, scientific notation. Standard notation is what we're doing. So standard notation to scientific notation. So here's how it goes. Scientific notation is some number times 10 raised to an exponent. So if I give you the standard notation of 1, 2, 3, 4, 5, 6, let's make it a few more numbers. Let's make it 381.23456. Okay. This is considered standard notation on the left. We want you to make it into scientific notation. So scientific notation means that you have the first digit, the ones place, is between 1 and 9. Then you have a decimal, and then you have any amount of numbers that follow, times 10 raised to the exponent. So when the exponent moves to the left, so in this case, our decimal moves left, the exponent is positive. When our exponent moves right, our exponent is negative. Okay? So we're going to do this first example. We're moving the decimal place of the 0 to the left because our first number has to be between 1 and 9. It can't be 381. Okay, so to do this, we go between every number is considered a decimal place. So 1, 2. So I get 3. This is where our new decimal is. 8, 1, 2, 3, 4, 5, 6 times 10. My exponent here is going to be, remember, if it moves left, our exponent is positive. It's going to be 2. So let's test this in the calculator. 3.8123456 times 10 to the second, 381.23456. It's exactly what our original number was. So this right here, just gonna highlight it. This whole thing right here is the scientific notation. Okay, now let's do an example of where we'll have a negative exponent. So we have the number 0.0009231. Our decimal needs to be between the 9 and the 2. It's going to move to the right. One, 2, 3, 4. So our new answer for scientific notation is 9.231 times 10 to the negative 4. And we can test that number out. I think the calculator will give it to us. Sometimes it doesn't. Sometimes the calculator actually gives you scientific notation. That's just a circumstance of the number. I forget what digits it starts to give you scientific notation. So there you go. It's 0.0009231. So this would be our solution of scientific notation. Okay, so let's talk about this problem right here. Use a pH equals negative log hydrogen ion. The variable pH represents the level of acidity or alkalinity in the liquid of a pH state, and the hydrogen ion concentrations in the solution determine the value of the hydrogen ion in moles per liter in the following liquids given their pH values. Express your answers in scientific notation with 3 significant digits. This right here, in this case, means 3 decimal places. Okay, so it means 3 decimal places of our scientific notation. So that would be an ideal solution. Remember, the exponent is just based on how you moved it. So we're using this formula right here. And our answer has to be in scientific notation. So it says the concentration of hydrogen ions in acid rain is blank moles per liter. So there's a shortcut here. the setup would be 2.3 equals negative log hydrogen ion. But instead of doing that, what you're going to do is you're going to make this a negative pH, because you have to divide out that -1. So then it becomes 2.3 with a negative log hydrogen ion. So here's the shortcut. It's going to be 10 raised to negative 2.3. And then convert that to scientific notation. The reason why it's negative 2.3 is because this is a base of 10. Remember, if it doesn't show it, it's automatically a base of 10. So you're changing it to exponential form for the shortcut. So shortcut is base 10 raised to the negative pH. Whatever the pH sign is, just change the sign to the opposite sign. Negative 2.3. So then I get 0.005011187. I just want to write down all the numbers, or as many numbers. I just write a lot of numbers down. So we're going to make the scientific notation and then 3 decimal places for that scientific notation. We have to move our decimal between the 5 and the 0. So 1, 2, 3. So our value is going to be 5 point, and then I need 3 decimal places here. So this 8 is greater than or equal to 5. So we have to make that a 2. 0, 1, 2 times 10 to the negative 3. Because it moved right 3, so that's a negative 3 exponent. This is my solution. Now you have the concentration of hydrogen ions for the milk. We're going to just use a shortcut. The shortcut says you're going to take 10, raise that to the negative pH. And then in this case, our pH of the milk is equal to 6.2. So it's going to be 10 raised to the negative 6.2. And then using the AB, negative 6.2. And it already gave it to us in scientific notation, but you need 3 decimal places. So 6.3. 6.310 times 10 to the negative 7. Rounding, this part of the decimal does not change that. So this stays the same.